Hello, Mrs. O'Donnell here. Tonight we are going to be working on the discriminant. This is a special part of the quadratic formula. Let's see here. Our goals for tonight are to determine the number of solutions by using the discriminant. Okay, we do have our forms. The forms are posted and the videos will be posted as soon as I finish making them. Please make sure you're coming to office hours with questions or emailing me. All right, so just a quick refresher. What we learned earlier this week is we learned that the quadratic formula is our quick, steadfast way to solve any quadratic formula, any quadratic equation to give us our x-intercepts, as long as our quadratic equation is written in standard form, set equal to 0. The fun story that I gave you guys is posted here, but I also asked you to create your own. Okay, so I'm going to go over this one, but hopefully if you have your own as well, you're kind of replaying that in your head, right? So there once was a negative boy who was unsure about going to a radical party. The boy was a square, so he lost out on 4 awesome chicks, and the whole thing was over by 2 a.m. And that's going to tell you your x-intercepts. Okay, now, if we think about All right, so let's just refresh a little bit. We'll kind of do a little backwards thinking about what equation led to the correct setup of this quadratic formula. All right, so what we want to do is we want to identify our A value, B value, and C value and kind of work backwards to plug them in to figure out what our quadratic equation was, right? Well, we know that the first letter is that letter B, okay, but it's after the negative sign, so it's going to be the number 3. It's going to be B. And then we know we've got b squared minus 4 times our a value, which is this 2. So we know a is going to be the number 2 times our c value, which is the number -5. And then we can also verify using the denominator there that that number 2 is our a value. All right, so I could go ahead. I know I have an x squared term. I have an x term, and I have a constant. Let's see here. I also have a constant term, and it's all going to be set equal to 0. So I can take my 2. I'm going to go ahead and plug that right in for that leading coefficient. I'm going to plug that 3 in for that b term. I'm going to plug in that -5 right there at the end for that c term. And voila, we've done a little backwards thinking to get to our original quadratic equation. All right, so at this point, what I want you to do is I want to start taking a look at the discriminant. So I want you to take a minute, I want you to pause this video and solve each of these 3 equations using the quadratic formula. Okay, we'll come back together in just a minute and we'll take a look at some of those results. Simplify it down as much as you possibly can. All right, so you should just be coming back now. Let's take a look at what you might have gotten. Okay, so this isn't quite simplified as far down as you possibly could have gotten, but it's pretty far, right, for each of the 3 equations. So what you might notice for this first equation is you couldn't get any farther than this 3 plus or minus the square root of -63 over 18. Okay, and you may also notice that this quadratic does not cross our x-axis. Okay, so there actually are no solutions or no roots for this quadratic. And this -63 is a big indicator of that. Okay. For this next one, this middle one, you may have taken it all the way down to find your solution is right here at -2, right? 8 plus 0 divided by -4 is -2. 8 minus 0 divided by -4 is also -2. There's only one solution at x equals -2. And our graph touches our x-axis right one time at -2. Okay, and then for this last one, you'll notice this, so that 0 really showed us a lot. This 61, the square root of 61, doesn't work out very nicely. Okay, so you do have two roots. You may have to do some rounding here. Our square root of 61 comes out to be about 7.8. So then you had to do 9 plus that square root of 61 divided by 2 to get, 8.4 rounded to the 10th place. And then you had to do 9 minus that square root of 61 divided by 2 to get about, we'll round it to the 10th place and call it 0.6. Okay, so those would be your two solutions, rounded estimated solutions. X is approximately 0.6 and X is approximately 8.4. Those would be your two solutions there. Okay, and so you notice this number that you have underneath your radical sign here, you have a positive number, so you're going to be both adding and subtracting from that 9. Here we have the number 0, so it didn't matter what we added or subtracted from that number, that digit, we would just be left with that number 8. And since we had a negative here underneath that radical sign, we ended up with this unreal answer. If you tried typing that into your calculator, you would get an error telling you that you have an unreal number. Okay, and for the purposes of Algebra 1, we're not going to talk about imaginary numbers, although if you're curious and you're at home and you're bored, I would challenge you to go ahead and Google that or shoot me an email. I have some great resources. You could learn all about imaginary numbers just for the fun of it because they're pretty cool. All right, so the key you might have noticed is that we're really paying a lot of attention to that, the number that ends up underneath of that radical sign, and that's what you call the discriminant. That is the discriminant of our quadratic formula. All right, so let's go ahead and take a look. We've got this polynomial x squared minus 12x plus 36 equals 0. We could go ahead and plug it all into our entire quadratic formula, which I've got up here in the corner just to give us a reminder. But we could also just grab our discriminant. If that's all we're really trying to do is figure out what's going on with our roots, we could just grab that discriminant and see what's going on, right? So our b value is at negative 12, so we're going to do negative 12 squared minus 4 times 1 times our c value, which is 36, right? And let's see here, negative 12 squared, that gives me 144. 4 times 1 is 4, times 36 is going to give me 144. So 144 minus 144, that gives me 0. All right, well, I remember from before, if I have 0, the square root of 0 is just 0, so I end up with just one root. So I have, if I'm describing my roots here, I have one real root, okay? My parabola, if I was trying to sketch do a quick sketch of it, let's see, I think I'm going to have a negative root. Probably, this looks like it factors down right here at like negative 6. I didn't do a great job. It should be touching, touching your x-axis. All right, let's take another look at another example. The first thing hopefully you'll notice is that we're running into a problem. We don't have a quadratic written in standard form. So that's always the first thing we have to look for. Okay, so I have to make sure it's written in standard form, set equal to 0. So I have to get rid of this negative 4 by doing a plus 4. If I do it to one side of my equal sign, I have to do it to both. So I have x squared plus x minus 2 is equal to 0. And now I can go ahead and just check out that discriminant to see kind of what is going on here. So my a value is 1, my b value is 1, my c value, a is 1, b is 1, c is negative 2. If I'm plugging in to my discriminant, I am plugging in b squared, so 1 squared minus 4 times a times c, right? And let's see here. That's going to give me, this is my discriminant, that's going to give me 1 minus, let's see here, 4 times 1 is 4, times negative 2 is negative 8. 1 minus a negative 8, that's going to give me 1 plus 8, which is 9. Okay, so my discriminant right there is 9. And that tells me that, okay, if I take the square root of 9, I'm going to end up with, a plus or minus 3. So I'm going to be both adding 3 and then dividing, or subtracting 3 and then dividing. I could even go back, kind of work a little backwards and fill in the rest of that quadratic, right? Negative 1 plus 3 divided by negative 4. So that's going to tell me that I have 2 real roots or real solutions. If I wanted to kind of sketch a quick graph, I'm going to have a negative and a positive, and I know my parabola is going to open up, so maybe it's something like that. And I can kind of go from there. You could obviously get a lot more detailed by actually following through and finding what your solutions are. But for our purposes, we're just describing the roots. We're going to have 2 real roots. All right, let's take a look at another one. I'm going to challenge you right now to go ahead and pause the video. Try this problem on your own. See if you can describe the roots of the given polynomial. And then we'll come back in a minute. All right, so you've just unpaused the video. Let's take a look at it. So first thing first, we have to get our equation into standard form. 2x squared plus 3x minus 20 equals 0. I subtracted 20 from both sides of my equal sign to get this minus 20 here. Then let's see here. I've got a is equal to 2. B is equal to 3, and C is equal to negative 20. So if I'm going to go ahead and take a look at my discriminant, I can plug in B squared minus 4 times A times C. And I can follow order of operations. Please excuse my dear Aunt Sally. I'm going to do my exponents. 3 squared is 9. Let's see here. 4 times 2 is 8 times negative 20. Well, 2 negatives, let's see, I can keep that minus with my 8. 2 negatives multiplied to make a positive. So 8 times 20, that gives me 160. That gives me 169 when you add 9 to it. And I know that that's my number underneath my radical. So if I take the square root of 169, I'm getting a positive 13. So that tells me I have a plus or minus 13. I'm going to have to do 2 separate equations. That's 2 real roots right there. 2 real solutions. 2 x-intercepts, right? You could say it any of those ways. 2 real roots, 2 real solutions, 2 x-intercepts. Okay, if you really wanted to, you could sketch a quick graph, right? We'll be adding 13 and subtracting 13 from, let's see here, B is 3. And that's all over 2a. 2 times 2 is 4. So we'll probably have a negative and a positive root. And our leading coefficient is positive, so we're going to have a quadratic that's maybe something kind of like that. Okay? Just for a quick sketch. That's not very accurate, but just a quick sketch. Okay, so let's do a quick summary from what we've talked about today. Today we learned about the discriminant. Oh, M-I-N-A-N. Discriminant, something like that. Okay, and the discriminant is that part of the quadratic formula that's underneath the radical, right? So that b squared minus 4ac. It's that number under the radical, okay? And if you have a positive number under the radical, then you're going to end up with 2 solutions, right? If you have 0 under the radical, you're going to end up with 1 solution. And if you have a negative number under the radical, then you will have 0 real solutions. Okay, when you get into algebra 2, you'll learn about imaginary numbers.